In this lesson, we are going to look at LOOCV, or leave one out cross validation. So, LOOCV, or leave one out cross validation, is related to and tries to take care of the shortcomings of the validation set approach. It also has a training set and a validation set, but operates slightly differently. So, only one observation, say x1, y1, is used for the validation set. So, x1 could be a vector of the x variables for the first observation. All of the other n-1 observations, say x2, y2 through xn, yn, constitute the training set. So, we fit the model on the training set observations, which has n-1 observations. So, and then you make a prediction y hat 1 for the validation observation x1, and then you compute mean square error 1, which is shown there. So, that is an approximately unbiased estimate for the test error. Note that MSE1 is a poor estimate because it is highly variable, again because it is only for one observation. So, what do? We repeat this procedure by selecting observation x2, y2 as the validation set and the other n-1 observations as the training set. Then we compute MSE2 similarly to the way MSE1 was computed. And then LOOCV repeats this a total of n times to give us n mean squared errors, MSE1 through MSEn, and the estimate for the test mean square error is the average of these n mean square errors, and is given by this formula. It is 1 over n times the sum of these n mean square errors. So, assume that you have a data set with n observations, 1, 2, 3 through n. For illustrative purposes, again each observation is listed as a number. In this method, assume you have a data set with n observations, as shown in this figure. For illustrative purposes, each observation is listed as a number. So, we have seen this set of n observations. In the first step of LOOCV, x1, y1 is used for the validation set, that is observation 1 is used as the validation set. All of the other observations from number 2 through number 10 constitute the training set. In the second step of leave one out cross validation, the second observation is used as the validation set, and all the other n-1 observations, that is observation 1 and then observations 3 through n, are the training set. So, the figure to the right is a schematic representation of how LOOCV works. A set of n data points is repeatedly split into a training set shown in blue containing all but one observation, and a validation set that contains only that observation shown in beige. Then the test error is computed or estimated by averaging the n resulting mean square errors. The first training set contains all but observation 1, the second training set contains all but observation 2, and so on. When you compare LOOCV versus the validation set approach, LOOCV has far less bias since it uses training sets with n-1 observation, that is almost the entire data set, as opposed to the validation set approach where the training set is usually 50% of the original data set. Hence, LOOCV tends not to overestimate the test error rate as much as the validation set approach does. Secondly, performing the LOOCV multiple times will always give the same results, unlike the validation set approach. This is because there is no randomness in the training and validation set splits. Finally, LOOCV can be computationally expensive since the model has to be fitted n times. This could be a problem if n is large and if each individual model takes time to fit. So, in this lesson we have introduced the LOOCV approach.